Good morning, everyone, and welcome to our first webinar of 2023. If you've missed any of our webinars which have been going since 2020, you can view them all on demand right here on our YouTube channel or on our Learning Hub at www.proctorgroup.com. You can also now register for our online members area, where you can access product information libraries, personalised CPD certification, and our free online U-value and condensation risk calculation. As always, you can request product samples, arrange follow-up meetings to discuss the specifics of your project, or book one of our expanding range of REBA-assessed CPDs covering a range of topics. This can all be done either face-to-face with our team of experts across the UK or online. In this morning's webinar, we're going to consider the role construction membranes can play in retrofit projects and how they can help optimise building performance. Nottingham Trent University's recent report, Scaling Up Retrofit 2050, suggests, to meet the UK's climate change targets, we will need to improve nearly every home in the UK with energy efficiency measures at a rate of more than 1.5 homes every minute between now and 2050. It is also estimated that 80% of the buildings we'll be living and working in 2050 are already built. With that in mind, we can see how important a part of the net zero transition retrofitting the built environment is. We'll begin by considering the project goals and how to assess and define a realistic strategy to upgrade existing buildings. Then look at the hygrothermal characteristics of various common construction types and the different challenges they pose. After that, we'll move on to a solution that can be applied to enhance the energy performance whilst minimising moisture risks. As well as airtightness, we'll consider the effect of insulation specification and assessing and reducing the condensation risk. Lastly, we'll finish up with our regular Q&A session. The most important parts of any refurbishment project are gaining a solid understanding of the existing building fabric and performance, and then setting a realistic and achievable end goal which accounts for any inherent limitations. As with new buildings, the most useful start point to consider these goals is to look at the building fabric and layout, the occupancy levels and intended use of the refurbished structure, and the weather and environmental conditions to which it is and has been exposed. The main difference when dealing with existing structures is, of course, that there are more constraints imposed by the existing fabric. The internal space, orientation, and a large proportion of the hygrothermal characteristics cannot be altered, meaning a more focused strategy is needed than for a new build. This in turn means that there is a certain level of performance that will be the maximum that can be practically achieved within these constraints. So whilst it may be desirable to upgrade all the existing building stock to Passive House standard, in many cases this is either highly impractical or simply impossible to achieve. Developing a strategy for refurbishment works therefore demands a detailed understanding of these various constraints and influencing factors, in order to establish a realistic, achievable and economical solution. To develop this understanding of the problems and solutions, two useful references are the Passive House Institute's Airtight standard and the PAS 2035 document, Retrofitting Dwellings for Improved Energy Efficiency. These two documents address the issues in retrofit from different perspectives and taken together help develop a flexible and pragmatic approach to the delivery of best practice in retrofit. Airtight, being derived from the Passive House approach, focuses on illustrating best practice performance targets for building fabric and services, with the particular focus on good levels of insulation and minimum air leakage that characterises all such projects. In contrast, PAS 2035 takes a more practical approach and provides a framework for assessing practicalities and risks associated with individual works. These technical risk assessments outline how likely the interactions between various upgrade measures are to cause significant problems, and how complex each individual measure is in isolation. In this context, measures such as draft-proofing strips or hot water cylinder insulation represent a low risk, partly because their installation processes are straightforward, but also because they interact minimally with any other systems being installed. By contrast, whole house mechanical ventilation with heat recovery or internal wall insulation are considered higher risk, as the installation is more disruptive and the considerations and design process much more complex. We've covered both standards in more detail in previous webinars, so if it's of particular interest, you can find those both on our YouTube channel and the Learning Hub on our website. The important thing to note today is, though, that an important part of our building assessment must be to establish a balance between achieving a worthwhile uplift to the building performance and the disruption and technical risk involved in the required works. The other part of the building assessment is to investigate and develop a thorough understanding of the materials and construction types involved. This is important when it comes to avoiding moisture problems, as the hygrothermal performance of materials and their heat and moisture storage characteristics can have a very significant impact. For example, a solid masonry wall type could be anything from a single thickness brick right through to a foot of solid granite. Both would be masonry, both classed as hard to treat, but very different when it becomes a detailed assessment. How this detailed assessment is carried out can also vary, and guidance on this is given in BS 5250, the Code of Practice for Moisture Control in Buildings, most recently updated in 2021. For most types of constructions, the method recommended in BS 5250 is a simple Glaser method calculation using BS EN ISO 13788. This simple, steady-state assessment gives a good indication of likely problems, but it doesn't account for several aspects of particular importance in solid walls. Primarily, this is the moisture storage capacity and influence of external weather conditions. For this reason, BS 5250 recommends the more detailed BS EN 15026 assessment procedure in solid walls. This takes a more detailed approach accounting for most of the moisture-related factors influencing the performance of a structure, as well as orientation and physical location. This extra detail means it's often preferable to use the EN 15026 assessment more broadly than is required, as it can highlight problems that may be missed in the simplified assessment. The difficulty with this approach, particularly with refurbishment projects, is that the properties of the building fabric and materials used in the calculation must be appropriate and reasonably accurate. This in turn makes a good assessment of the type and condition of the existing structure critical. There is also little standardised guidance on this, so consulting an experienced and knowledgeable assessor is an important component of the process. This requirement for additional detail extends to the weather conditions, where the prevailing condition and building orientation are an important part of assessing the moisture risks. The hygrothermal performance of south-facing walls exposed to the sun will be different from a shaded north-facing wall, and striking a balance between these is important. Finally, the internal environment and occupancy patterns must be considered. The type of function of the building establishes the moisture load it's likely to experience, and the requirements for ventilation of the habitable spaces. The impact of wet trades on these conditions should also be factored in, as any works involving concrete, plastering, etc. will increase the initial moisture load considerably. These factors feed into developing an understanding of the management of the heat, air and moisture in the structure, and this holistic approach is fundamental to a successful retrofit strategy. Failure to consider the impact of each measure across the entire project can cause a range of problems, from internal wall insulation leading to hidden mould, through to poor air tightness reducing the effectiveness of heat pumps. Construction membranes have an important role to play in managing heat, air and moisture by increasing the level of control we have over these factors, especially if there is a degree of ambiguity over the existing fabric composition and performance. So how do we make use of membranes in refurbishment projects? Firstly, we need to consider the types of construction we are dealing with. The main types of wall likely to be encountered in refurbishment are solid masonry, cavity and timber frame. However, there are now increasing numbers of light steel frame and facade wall systems being upgraded. Each of these types presents different challenges when it comes to considering appropriate upgrades. To begin with, cavity walls are generally considered to offer the simplest upgrade path by simply filling the cavity with an appropriate material. Cavity fill insulation can take on many forms, from mineral fibre to closed-cell foam, and if installed correctly offers a simple and relatively fail-safe path to a useful performance uplift. If installed correctly is the critical part of that though, and there have been several instances historically of incorrect or substandard installations leading to problems. This can take the form of poor thermal performance caused by uneven fill or moisture problems where the insulation has become saturated. Ensuring an appropriate system is installed by a reputable and certified contractor goes a long way to help avoid these issues. In most typical cases, there is less of a role for construction membranes in cavity insulation projects, so today we'll concentrate mainly on the other three wall types. At first glance, upgrading framed walls may seem straightforward, as there is typically either a large void between the structure available to fill or existing insulation material that can be replaced with something better. From a purely thermal point of view, that perception is correct. However, if we add moisture control into the equation, the picture is not so clear. Timber structures in particular are more vulnerable to rot and decay than masonry walls, and timber can also warp and distort in response to moisture. This warping may also be historical, causing issues with the fitment of some types of insulation. So, let's first consider the most obvious approach and upgrade the insulation to a high-performance rigid foam. A major concern here is that the reduced vapor permeability of the insulation may lead to trapped moisture, where previously it was free to move throughout the wall. This problem is further exaggerated by the reduction in heat flow, making it harder for any moisture to dry out. If we then consider the airtightness of the wall, the use of a rigid board makes the installation tolerance critical. If the boards are not tightly fitted between studs, heat loss by convection may occur around the edges, a phenomenon known as thermal bypass. This convection may also introduce moisture into the colder areas of the structure, where it may further increase condensation risks. While installing rigid insulation without these gaps is certainly possible, this must be properly allowed for in terms of both timescale and budget. A poor quality, rushed installation will not work as intended. A possible solution to this is to use an air and vapor control layer internally, but again this must be correctly specified and installed to be fully effective. If the existing wall relied on a degree of inward drying out, then adding an impermeable layer may lead to issues. In this situation, variable resistance vapor control layer membranes such as our Project Adapt can provide a solution. This type of membrane varies its vapor resistance in response to environmental conditions, becoming more resistant to vapor in winter and more permeable in summer. In practice, this means the framing can be filled with insulation, then lined internally with the vapor control layer. This limits moisture ingress in the colder winter part of the annual cycle and provides an effective barrier to air leakage out of the heated space. At the same time, over the summer, the higher permeability allows the structure to dry out, removing any moisture that has built up over the colder months. This drying process will typically work better if a vapor-permeable insulation such as mineral or natural fibre is used in the framing. Such flexible insulation types can also reduce the likelihood of air gaps between the insulation and the framing, although this does come at the expense of a typically higher thermal conductivity. Depending on the assessment criteria used, this lower conductivity may be offset by the more airtight building envelope a well-sealed air and vapor control layer can provide. Airtight, for example, includes means to incorporate air leakage rates. Currently, however, the national building regulations in all areas of the UK and Ireland do not set a standard for air leakage. In contrast to a framed wall, a solid wall very rarely has a substantial cavity to work with, so any meaningful increase in thermal performance will necessitate increasing the wall thickness. The type and location of this increased thickness can lead to significant differences in performance, as can the nature of the base wall. In this type of wall, particularly when placing insulation internally, getting the right moisture control strategy is important, as if the dew point and condensation risk is not properly managed, it can lead to substantial problems. Although a lot of existing solid masonry walls offer very limited thermal insulation, the traditional plastered on the hard finish can be reasonably airtight if kept in good repair. On the other hand, traditional plasters and mortars can be very sensitive to changes in moisture levels. Depending on the nature of the thermal upgrade, vapor-permeable air barriers like our Airtight can be a good fit in this type of construction, as they can restrict the passage of air without having a substantial effect on the existing moisture balance. If we place the insulation layers across the outside, this has the advantage of keeping the masonry and plaster layers within the heated envelope. Keeping this masonry warm means the dew point occurs well outside of the sensitive existing fabric, and means the masonry can be used as a fabric heat store. Adding an external insulation system will also necessitate a new external weatherproof finish, and modern finishes will typically provide improved protection against driving rain and freeze-thaw cycles than the existing masonry. In this application, the Airtight can be placed over the existing wall to act as an air barrier without trapping moisture. Even where the existing fabric is airtight to a reasonable degree, a dedicated air barrier membrane can deliver more durable and consistent air barrier performance. What is being used is the external finish and the building type. An additional external membrane may also be used, which could be a further layer of Airtight, Airtight UV if open joint cladding is used, or ProBreathe A2 if fire performance is a particular concern. The principal issues with insulating externally are in increasing the footprint of the building and changing its appearance. Depending on the location and circumstances, these may not be desirable or possible. For example, historic buildings may not receive planning permission for such a substantial change in appearance, or the roof design may not allow sufficient space to accommodate the added thickness. In such cases, it's necessary to move the insulation internally. As we mentioned earlier, solid walls with internal insulation are the most difficult type of wall to design correctly in terms of condensation. Hence, BS 5250 recommends the more detailed EN 15026 assessment. These systems involve managing the balance of moisture from the living spaces entering the structure against the drying out potential. In solid walls, moisture from both these internal sources and from rainfall is stored in the masonry and released when conditions allow. The drying out is driven by both the sun externally and by heat from the internal spaces. If we add a large quantity of insulation internally, this can restrict the drying potential, driven by the internal heat source as the wall becomes colder. Furthermore, if the insulation is impermeable, as many high-performance rigid foams are, then the inward sun-driven drying can also be limited. If both these drying mechanisms are disrupted, the masonry cannot adequately release its stored moisture, leading inevitably to problems with damp. These problems may also be hidden behind the internal linings and not be immediately apparent. In this type of wall, Airtight can again be used as a moisture-neutral air barrier over the masonry, which will block air leakage without inhibiting the flow of moisture. Project Adapt can also be used over the inside face of the insulation to manage the ingress of moisture in colder conditions whilst reducing the impact on drying out. It should not be regarded as a magic quick fix, however, and neither is a substitute for detailed project-specific hygrothermal analysis. The insulation type and membrane specification must be well matched to the existing fabric, and all the systems must be well detailed and installed to provide the optimum result. Whilst permeable insulation such as mineral fibre or our Spacetherm aerogel will facilitate the movement of moisture more easily, it could easily be argued that using an impermeable insulation and VCL membrane to reduce the flow of moisture from the indoor environment as far as possible is advantageous. In practice, neither solution is perfect, and hence the need for detailed analysis encompassing the building's fabric, location, orientation, and purpose. The role played by construction membranes is to deliver known, tested, and consistent performance that can help reduce the effect of assumptions regarding the existing structure and materials. The type of masonry used can significantly affect performance, with harder stones such as granite less able to store and transport moisture than sandstone or brickwork. Likewise, lime-based mortar is very different to cement-based mortar, so it's important to know precisely what materials are involved when considering how to proceed. The final type of wall we'll consider is facade walls. While certainly less common in refurbishment projects than the other walls we've discussed, change of use or recladding projects may require consequential upgrades to thermal performance. In a typical steel frame facade wall, the bulk of the insulation is normally placed outside of the sheathing, which is typically of cement fiberboard or similar. Historically, the airtight line in such constructions would be provided by an internal vapour control layer, if at all. Now, however, the Airtight used externally over the sheathing provides an alternative. Placed out with the structure, there are fewer penetrations through the air barrier, and the vapour-permeable Airtight permits the escape of moisture. The membrane can also provide robust weather protection during construction, as being self-adhered to a rigid subbase, it is less likely to blow around and tear than mechanically fixed alternative. In a retrofit context, this weather protection may be particularly important to avoid water ingress into interior spaces, which may still be in use or partly occupied during the upgrade works. On the outside of the insulation, a secondary membrane like the ProBreathe A2 can provide additional protection to the insulation, further limiting air movement and ensuring as-built performance is consistent with design targets. So we've seen how the various aspects of these construction types affect moisture control, and how some of the inherent problems can be designed out. What cannot be overstated, though, is that the most critical part of any retrofit project is understanding the fundamental changes unique to each project. Any retrofit project is a delicate balancing act of competing and conflicting problems and solutions, and a detailed, realistic, and well-developed plan is key to a successful project delivery. The tools to enable this are now well developed, with PAS 2035 outlining project scope and delivery, Enerfit establishing realistic and achievable performance standards, and EN 15026 enabling robust hygrothermal assessments. In this context, membranes provide reliable and adaptable solutions appropriate to a range of situations. However, Identifying the correct choice for each unique situation requires good communication between suppliers, installers, and the wider project team. We'll be discussing the specifics of such one project in our next webinar, so please make sure you subscribe or register if that's of interest. And on that note, we'll now move on to the Q&A session. Good morning, everyone. Welcome to our first webinar of 2023. From a very chilly Scotland here, I hope everyone had a wonderful new year and wishing you all the best for this year coming. We now have over 120,000 views of our webinars, and we have a very exciting programme for this year, so I hope you can all join us as we go throughout the year. As you know, we will try our best to answer all your questions, so please ask them either here on YouTube, email us at webinar@proctorgroup.com, or you can also direct message us on Twitter @proctorgroup. If you'd like to request a product sample pack containing the materials discussed in this webinar, or book a meeting with one of our staff, you can do that now on our webinar page. Little day for the diary. Next webinar will be Friday the 24th of February at our usual time of 10 a.m. and this will be a Wrap-Tight focused products in practice webinar, and we have some very special guests from Comfort Frames project delivery team. So it's a real live product in practice case study, so please come along and join us for that. If you've registered for the webinar today, you'll receive a follow-up email with all of these links, plus a link to the replay. Late registration is now open for this week's webinar if you would like the replay link. And please feel free to circulate that with colleagues, friends, anyone who might find this of interest. It really helps us if you give us a thumbs up on our video if you've enjoyed it, and also if you subscribe to our channel, that keeps you up to date with anything that's forthcoming. We post a lot of different things on our YouTube channel, installation videos, product updates, company updates, so please subscribe, and that will make sure that you get notifications as and when they arrive. So this week we have some familiar faces, so no guests this week. We've gone with an all Proctor team this week, so I'll just introduce them very quickly for anyone that hasn't seen these lovely faces before. So good morning, Ian. Ian's our technical director.
Good morning, Keira. Good morning, everybody.
Good morning. Will Jones is our head of business development. Good morning, Will.
Good morning.
Morning. We have Jay Finch, who is our London specification manager. Morning, Jay.
Morning, everyone. Good morning.
And Mark Blackie, who is our regional sales manager. Good morning, Mark.
Good morning, Keira. Good morning, everyone.
Fantastic. So I'm just going to start with, we've had a lot of questions already on the YouTube feed. We've had quite a number through email and Twitter, so please bear with me. If I happen to miss any, I apologise in advance because they come in a lot of different platforms. We will get back to you. But as I say, we'll stay on as long as we can to try and answer everything. So Ian, Ashley has asked, what is the most important thing to address in refurbishment?
A good question, Ashley. I'll use my common theme, depends. I guess when you're looking at a refurbishment, it depends on what you want from that refurbishment. Is there a rain a problem? Is it you need to change something, correct something? So is rain a problem? With the new energy costs, do you need to improve the insulation? That's probably one of the main factors. Is it just aesthetics? And if it's the aesthetics, what will you do that will affect the rest of the building? So sort of use the word depends, but it all depends on what you're looking for from that refurbishment. And I guess to answer what's the most important, I guess there's nothing more important. Everything's important. So you've got to think of the project holistically, and if you're doing anything, what effect will that have on the rest of the building? Moisture being one of the main things to look for. So I guess if you phone us, we can discuss further and really get to the crux of what you want to do in the refurbishment, and we'll help you as best we can.
Good. So just following on from that, Will, if I can come to you, James has asked, so what do you think is more important to improve, insulation or airtightness?
Okay, a wise man once said it depends. So I think on this one, they're equally important, but the most I guess the thing we're going to try and do with this is find a balance. I'd say in the first instance, an assessment of the property is absolutely imperative. We need to understand the facts before we can really answer that question, I guess, accurately. So we need to understand the floors, the walls, the roof, the doors and the windows and how they perform. It's a potential that the building could lose most of its energy through unwanted air movement. So spending lots of money on improving all your thermal performance of that building, it's going to be futile, really. I'd say in the first instance, you should really be looking at getting an assessor on board to sort of get a full assessment of the property that you're trying to improve. That way, you're going to understand which direction you should take that in. So whether you're going to be sort of focusing on the thermal performance of that building, certain areas that might need treating more than others due to sort of unwanted air movement and leaks, drafts, that sort of thing. And that hopefully will then obviously be able to guide you to create or improve the building so it's healthy, energy efficient, and obviously better to live in.
Absolutely. Thank you very much, Will. Mark, Greg has asked again on YouTube, I'm going to come on to some of the email ones in a minute. What are the ways to improve airtightness and U value without disturbing the external facade of my building?
Well, of course, there are many ways to insulate from the inside of your dwelling, but many of the insulation products on the market do tend to be bulky, which will lose you some internal space, and they're not particularly airtight. One of the ways you can insulate from the inside without losing too much room space and gain that sufficient airtightness is to use an airtight membrane bonded onto a high-performing thin insulator, such as an aerogel. So we've got a product, WrapTherm, which combines the qualities of a self-adhesive airtightness layer with WrapTight, which is then bonded onto our SpaceTherm aerogel blanket. Now, the beauty of that is that the combination offers great airtightness and an improvement in thermal performance, but at a greatly reduced thickness, which is typically between 15 mil and 25 mil.
Fantastic. Thank you very much, Mark. Jay, I'm just going around the houses here, so one by one, and then I'll come to more of the specifics. Daniel has asked, do Proctor Group have any membranes which are Passive House Airtight certified?
Should I start that by saying depends? I'm joking. Of course we do.
No
And
more
as a
depends.
business,
No, I'm kidding.
it's something we really advocate. I mean, any material which is going to improve sustainability and reduce the energy consumption of a home, it's a really good path to head towards. I'm pleased in the presentation we touched on Retrofit, because building designers and constructors will all realise that it's actually more challenging to work with an existing building. There we go. And I think with the flexibility, we look at the Passive House standards within the Retrofit campaign, that they really are much more easy to work around. And I think Retrofit in that sense is a really fundamental key. So yes, absolutely. We have a number of products, particularly something like WrapTight we covered earlier and ProCheck Adapt, that are really appropriate for use in this sector. So I think if you have an opportunity, I'm not sure if these come in by email if someone's asked, but ultimately if you have an inquiry, we've got a technical team that can assist. But fundamentally, let's look at some real practical options in terms of samples and enter some kind of dialogue to see how we can help. So yes, we do absolutely have a number of products.
Okay, thank you very much, Jay. Will, Doogie has asked an external wall insulation application where WrapTight is used beneath the insulation. Would WrapTight stick to an existing finish like dry dash render, or would the render need to be removed?
Hi, Dougie. Thanks for your question. I suppose the problem with a dry dash render is it's not very level, if at all, really. So trying to adhere a flat membrane back to a substrate such as that wouldn't be ideal, no. So ideally, you'd want to be putting WrapTight back to a fully level substrate that was dry and obviously relatively clean and dust-free. So yeah, in that instance, probably best if you sort of come to us at that point, and we can come and have a look at the property and see what needs to be done in order to how we sort of get around that. But in short, no, you wouldn't want to put a fully adhered membrane straight onto a dry dash.
Okay, good. Thank you, Will. Ian, Dave has asked, on the system where you showed internal insulation offset from the wall, creating a void, do you have a certified system that would meet PAS 2035 design?
Good morning, Dave. I think we've spoken on this channel before. No, we don't have a certified system. We do have solutions for that, and we are doing some 2035 solutions. But in terms of a certified system, there is no certified system for any of our solutions in terms of the SpaceTherm solutions, which are perfectly acceptable, but sometimes they just don't have the paperwork. Don't get me started on certification, but it has a place for it. It's not the be-all and end-all, and sometimes that bit of paper cannot be as good as the actual solution that you can provide. So we can provide very good solutions, and they're proven systems, and we're very happy with them. We just don't have to go through the pain of sometimes certification.
Good. Ian was recently invited to do a seminar talk at a big exhibition around the challenges of certification, which he was probably the best 45 minutes of his life, enabling him to talk about the challenges in the construction sector of certification timing and costs and whatnot. So it is a challenge. Mark, if I can come back to you, please. This is one we've had from email from Simon. I'm looking to renew my current roof due to inherent leaks. We'll also be looking to upgrade the loft as another habitable room. How can I ensure that I can achieve the best possible airtightness in this situation?
Oh, good question. So in that scenario, you may have a mixture of cold and warm roof buildup. So we do need to be mindful about condensation control. Now, historically, the method would be to make sure that you've got a well-sealed ceiling, or with the introduction of a vapor control layer at ceiling level. However, in practice, that might be quite difficult to introduce with service runs and junctions, and it does rely heavily on the quality of installation. So one of the ways you could overcome this is making the entire roof warm by placing the insulation running in line with the roof, and then using an external air barrier. Now, a self-adhered air barrier would bond straight to the insulation board, and rather than being mechanically fixed, and it would offer you some secondary protection whilst the primary covering is being reinstalled.
Absolutely, spot on, Mark. Thank you. Jay, another email one. I'll just come back to you if that's okay. Derek has asked, if an airtight membrane is retrofitted into an older property, will this increase the condensation risk?
Yes, absolutely. We have to be really cognizant of the fact that whenever we're controlling air, we will end up controlling vapor or moisture. They are kind of inseparable to a certain degree. So yes, absolutely, it can present a risk. So we have to come up with some kind of strategy. It's a challenge, and we think back historically, lots of the membranes that we see now weren't there. So we've kind of created this sector in the marketplace through low energy, high performance homes, where we need to really carefully focus on moisture. And I appreciate we've covered this through some previous questions, and we looked at it through the presentation earlier. But it's very important that we come up with a strategy through an appropriate membrane to make sure that that vapor is exfiltrated through the property and it condenses outside. We don't want that to condense internally. So it's very important when looking at the specification of any wall assembly that there isn't a one-size-fits-all solution. It is very specific to that property, to occupancy, location, etc. So it's something we have to look at really early in the design stages to make sure that we don't inadvertently create some kind of inherent risk. So the answer is yes, hence having to put so much attention to make sure that we don't stumble across it.
Good, thank you, Jay. That's great. Ian, another regular of our webinars, Charles, has asked, restricting movement through the wall, will it not drive it towards weaker points, such as external wall intermediate floor junctions, causing more problems there?
It's a good point, Charles, and well thought through. Yeah, if you're going to move the moisture, or you're stopping the moisture from one area, you've got to think about where the moisture, where else it could go. So yeah, it's very true. You've got to think of this whole thing holistically, and by doing one thing, what effect does it have on another? So Charles, it's a great question, and in theory, yes, that could happen. So you'd have to think, where you're just addressing the walls, you will have the floor, intermediate floor, to consider where that moisture is going. There is some systems you can use around the floor zones. You can see shoes that you can insulate around the joist, but you've got to think of it holistically. It's very true. So if you speak to Proctor's tech desk, we can help you out with what types of insulation you can use. Going back to Mark's point on the types of insulation, vapor permeable, in that area would be the best option. High performance vapor permeable insulations, so we can reduce that cold bridge and reduce the effects of anything that you may be doing to the wall in that area.
Good. So just dealing with the knock-on effect.
Yeah.
Perfect. Thank you very much. Questions coming thick and fast, which is fantastic. Mark, Ben has asked, how do we go about getting an assessor for refurbishment projects? Is this something that Proctor provide?
Oh, thanks for the question, Ben. We don't currently provide an assessor, but what we can do is put you in the right direction for where you can get that assessment to be carried out. So get in touch with us, and we can go through the kind of requirements that you need, and then put you in the right direction.
Okay, perfect. Good. Okay, and Mark, while I'm speaking to you, we have one around ground gas protection, which I know you know quite a bit about. So if I can just jump on this question for you here from Dwayne. Quite a long one, so bear with me. Can ground gas protection be installed retrospectively? I've recently applied for planning permission to build an extension and have been notified that I will need to install ground gas protection in the extension. Obviously, I'm now concerned as our house was built in the 1950s. I assume there's no gas protection at all. Is it possible to install gas protection into the existing house?
Yeah, this question does come up specifically when people are looking to build an extension to an existing dwelling. The short answer is yes. And then most homeowners want to add gas protection to an existing house. There is guidance known as the retrofitting ground gas protection measures, and our national ground gas manager was involved on the steering group for that as well. So again, come and speak to us, and then we can give you some advice on that. But as you can imagine, it's not as simple as installing a protective measure during the construction phase, but we can reduce the risk fitting it retrospectively. Okay,
fantastic. Ian, if I can come back to you, please. We have a question here from Rob Warren, who again, nice to see you here, Rob. It says, great presentation and explanation of the complex balance between moisture insulation and airtightness. Given that all properties have an EPC and each EPC has recommendations on how to improve energy efficiency, is this a good place to start when considering the measures to consider when retrofitting your home, or does it depend?
Great comment, Rob. Good to hear from you. Yeah, there will be a list of recommendations to go with the EPC. They're useful. They tend to be a bit generic. I would say, well, obviously I'm going to say phone the tech desk and we can talk you through them, but sometimes they can be a bit generic, and they are a good place to start with coming with some obvious ways to improve your insulation or how to improve your energy efficiency. So you can do those, but you can also speak to proctors, and we can help advise holistically of what else. Yes, you can improve the insulation, but what, as Keira said earlier, what the knock-on effects would be. So yeah, it's a good place to start, but it's not the be-all and end-all of all recommendations.
Thank you, Ian. Will, I haven't spoken to you for a while, so I'm going to come back to one of the ones we've had via email. Can you tape and fill space there wall liner? That was from Joe, sorry.
Okay. So for those that don't know, I guess space thermal liner is a aerogel blanket that comes bonded to an MGO board, great for sort of internal wall insulation, sort of finishes where you're looking at sort of I guess where space is restricted. It comes with a square edge rather than a tapered edge. When you're sort of taping and filling, you kind of need a tapered edge really, ideally, to go for that approach. It can be done, but you're going to have to sort of make sure that you're feathering off your any sort of plaster you're using across the tape. The tape will probably sit proud of the butt joints. So ideally, you'd go for a skin finish. In all honesty, and I guess on that as well, if you're gonna use a plaster skin finish, then a primer should be used, ideally such as plaster bond.
Okay, fantastic. And Will, I know you're involved in some external wall insulation projects that we're working on. Sarah has asked, would a super insulant such as aerogel be suitable for hard to treat areas in EWI, in an EWI retrofit project?
That's a good question. We recently, I said the last sort of six months mainly, we've been asked quite a lot about using space therm in EWI systems, especially behind the likes of meter boxes, where it's kind of hard to treat area. You're really struggling for space. And in short, it does seem like a great product. The way that a space therm blanket can be used, the fact that it can be manipulated, it can be cut to size, it can be fixed back to a suitable substrate, it does tend to lend itself to such a system. Where we have to be careful is making sure that the product is obviously tried, tested, and certified so it's suitable. We're working on that, in short. We don't have potentially a certified system today, although the product does seem to be ideal for that situation. But yeah, leave that one with us, and hopefully in the not too distant, we will have a solution for sort of EWI, hard to treat areas, and obviously where we're struggling for space.
Okay, fantastic. Thank you, Will. Jay, Alan has asked, and other panelists, please jump in on the back of this because it's one to the panel. But Jay, if I can come to you first, what do the panel think about the drive to net zero and the conflict in preserving heritage interiors? Is there a balance that can be achieved?
If I answer the second bit first, it will help to put things in context. Now, in London, there are lots of older properties that can't be adapted. They'll be retained for lots of reasons. Spaces at a premium. So when you're looking at internal features, particularly we might see plasterwork or some kind of part of that character that can't be removed. You're absolutely right, Alan. It's impractical and very often impossible to put a large swathe of insulation on the inside. So we acknowledge that. We have a range of products within our space therm family, which are aerogel based. So we're getting down to some really good low U values without impeding on that structure. So we think about perhaps plasterwork. It doesn't need to be removed. There's no kind of disruption to that, but it also doesn't cover it over. So if you can get down to these low values in a combination with a very strategized approach, then ultimately, yes, it kind of dances very cleverly around that. And when we ally that, of course, to the whole model, not just in older, perhaps listed buildings, but across the board about this premise that we have now about retrofit first, as we've seen with the Architect's Journal, the premise to all of that is to have a much more sustainable model. It's much easier for us to look at that in that sense and refurb existing, problematic in terms of construction, I know, but it's easier from getting down to a net zero perspective. So as an organization, and I hope others can qualify this a bit better, but it's something we actively drive towards. Any step we can make towards being more sensible and responsible for the moves that we make, our products and our services and our approach to the market fully support that. But ultimately, yes, it's a good question, Ellen. If you have questions when you're looking at older properties, then that's a very long discussion. So if you send us some detail, we'd happily assist, of course we will.
Fantastic. Anyone else, anything else to add to that, or has Jay summed it up quite nicely?
Sorry, can you repeat the question again, Keira? Sorry,
My goodness,
enthralled with Jade's response there.
Let me find it. Goodness me. Okay, so what do the panel think about the drive to net zero and the conflict in preserving heritage interiors? Is there a balance that can be achieved?
Yeah. Sorry, heritage buildings. We were involved in European research, which was over 2 years long. Don't know whether we'd be invited now, given Brexit, but this was pre-Brexit where we were speaking nicely. So we would looked at how you would improve the energy efficiency of historic buildings. And these are real historic buildings where you can't really do anything externally for obvious reasons. Coupled with that, you can't do anything internally. Coupled with that, the majority of them were solid wall. So how do you improve the energy efficiency of those? What there was a small void behind the lath and plaster of these historic buildings. And we were tasked, Proctors were tasked, with trying to test as well, and it had to be removed as well. So you couldn't just put it in and leave it there. There had to be an option to take that insulation out if there was a different decision at a different time. So we came up with a aerogel system that you could blow into that void, and we got very good results with it. The difficulty was the price. That the original price of aerogel is not the cheapest, but then you had to condition it in such a way in tiny cubes that then could go into the feeder and then goes into the blower. So yeah, you could do it, but it was really cost prohibitive. Now, yeah, saving energy efficiency, that might tilt the balance slightly and become commercially more viable. But it was a good piece of work, but more academic than actual commercial.
Yeah, hard to apply to real life situations. That was a great project, though. I remember that. That kind of links a little bit with Mark's question around, what's our view on injection expanding foam insulation products, Ian? So again, he's talking about behind lath and plaster. Do you have a thought on that?
Yeah, injection foams can be useful. I would tend to think, again, from a holistic point of view, the heat, air, moisture balance. The first question would be, how breathable is the foam? There is some foams that are breathable. So you first would check with that. And yeah, you can use them. I would always use experienced installer. When you fill cavities, sometimes you can get a blockage and you think you filled the cavity, but you haven't filled it completely. So yeah, the foam insulation can be good, but I would always, first of all, look at the breathability of them and what effects that might have if it's not breathable enough.
Thank you very much indeed. Peter has asked, Ian, if I can come to you, not Ian, sorry, I've just come from Ian. Will, if I can come to you for this one, please. Peter O'Donnell has asked, on flat warm roofs, we often have insulation laid to fall where impermeable foil-backed PIR is fixed over. What is the best method to control moisture from room to underside of the deck? And is VCL ceiling level required? We can end up with significant space below deck to ceiling, sometimes over a metre. Now, I know some other people have kindly responded to Peter on the YouTube feed, but Will, can you give us your thoughts on that, please?
Yeah, I know it can be really tricky in certain flat roofs to sort of install a VCL. It would certainly be best practice to install a vapor controller in this application. It's important to note also that I'd say it's imperative you get a condensation risk analysis completed as well, because you need to understand what's in that void. There might be existing insulation sort of below the deck. I couldn't hear if it was a metal deck or a concrete deck, sorry. But understanding if there's any existing insulation or what the actual build-up is, we can then truly get a good picture of what's required. So in answer to the VCL, I'd say yes, that I'd always go for that as a good practice. I mentioned foil or PIR boards, which obviously although they obviously do restrict and can trap moisture and create interstitial condensation, they're normally sort of not taped or they're butted, so there will be some moisture that can escape through the board joints itself. Again, the condensation risk analysis should be able to show that. And because you're insulating over the deck as well, you've got a warm flat roof, so you'd expect any sort of risk to occur above the insulation and underneath the waterproofing layer, which is kind of where you want it to be in a flat roof. So yeah, I hope that answers the question.
Yes, thank you, Will. Some fantastic questions. I'm coming on to the sort of last 3 or 4. So if you have any more, sorry,
that one. Sorry. Yeah, the flat roofs is an interesting one. I'm guessing this is a refurbishment option. You know, are they talking about there is a flat roof there with the felt there, and whether you need a vapor control layer on the underside? If it is a refurbishment, you could use our ProCheck Adapt, for example, on the underside with the vapor control layer, because that would allow the drying out of the flat roof. However, there may be an option, depending on the insulation levels, to do a roof over the top, insulate on top of the roof felt. So it creates a dual roof. So you've got so much insulation below the felt and then more on the top, which is a very effective way. So it's similar to the EWI way we've looked at external wall insulation. It's effectively an external flat roof, sometimes called an upside down roof or an inverted roof. Certainly back in the day when we did a lot of styrofoam, that was quite a popular method. So in terms of refurbishment, it might be possible to do an inverted roof on top.
Yeah, absolutely. Thank you. Sorry about that. I was looking at my questions, Ian. I didn't see you trying to add. Thank you for interjecting. No problem at all. Actually, Ian, maybe you can help with this one from John. I think I missed it a little bit earlier on the feed here. Sorry, John. What is a best practice approach for improving thermal performance and airtightness in line with PAS 2035 of traditional A-listed properties without disturbing the listed fabric items such as skirtings, cornices that were not permitted to disturb? Oh, you're on mute.
Yeah, the cornices and skirting boards look absolutely brilliant in some of these old houses. But how you actually maintain them is really difficult when it comes to refurbishment. We've got the wall liner system, which is only 10 millimeters of insulation with a 3 millimeter MGO board, which is a really good solution. If you have big cornices and skirting boards, but you're going to have cold bridging with that potentially if you want to keep that. So you'd have to look at what you do there. Unfortunately, with refurbishment, if you really want to insulate very well internally, you sometimes have to compromise the skirting boards and the cornices. So either take them off and replace them, or take it the fact that you're going to lose that aesthetic look internally, but you're improving the energy efficiency.
Yeah, I had that conundrum recently renovating Victorian Cottage, and we had to make the sad decision to remove some of the cornicing in some of the rooms. We still use space there, of course, but we just couldn't preserve it in some of them, unfortunately. So that was energy efficiency versus aesthetics, as you say, never easy. But Jay, one via email here from Paul. Is there any guidance or frameworks I can follow for larger scale retrofit projects?
Yeah, I mean, we covered in the presentation PAS 2035, and allied to that, you got the PAS 2030 document. Just for clarity, PAS stands for publicly available specification. So if you're looking at the premise and the guidance within that, it actually relates to any size project, whether it's the cottage you've refurbished or going to a large housing estate, doesn't really matter. I know that these CPDs and presentations and the way that we kind of have a dialogue with customers, we often have lots and lots of terms and lots of technical stuff, and it's hard to remember it all. So essentially, PAS 2030 and PAS 2035 would be the first part to go to for your framework measurements and guidance and best practice. But that should also be underpinned, as we saw earlier on, with BS 5250. And in doing that, please also underline that you're looking at the 2021 version. There is one prior that used to be called the Control of Condensation 2016 version. That's now been redacted and updated. So those documents in tandem will look at the control measures, your typical refurbishment and refit type measures, but fundamentally to make sure that you're dealing really cleverly, as we keep talking about, your condensation and your moisture control measurements. So essentially PAS 2030, 2035, and then underpinned by BS 5250.
Thank you, Jay. A comment from Alan here. I think we've covered this with regards to the interiors versus upgrading, but he had said, interesting, and thank you for your thoughts. With 80% of residential buildings that will be around in 2050 already built, great statistic. I wonder if we need to be controversial in preserving interiors versus upgrading. So I feel like we've already covered that, Alan, in some of the last questions, but thanks for that. It's crazy to think that 80% of buildings in 2050 are already here. Okay, coming on to the last few questions. I've got one via email here from Adam. I've got a couple via email, actually. Ian, is there an easier wall than others to treat in refurbishment?
I'll use the phrase that it depends. I guess all are different. I guess probably the hardest one, so going the other way instead of the easiest, the hardest type of wall would be the solid wall. Hence the reason hard to treat name tag. I would guess the easiest ones are probably the cavity walls, the masonry cavity walls. Most of those cavity walls have been filled already. Certainly in my last house, I had a cavity wall, a very neat cavity wall. I was able to get that insulated in a day. So a 4-bedroom house, insulated within a day, cavity wall, fantastic job by approved installer, no disruption to the house, improved the energy efficiency, also improved the acoustics as well. So that was an easy one. The house I'm in now is a solid wall, and that's going to be a lot more disruptive. I'm hoping to get some aerogel to maintain the breathability, and some adapt on the inside of that, which will provide a good solution. But there's a lot more disruption with that. So yeah, easiest way would be a cavity wall. External wall insulation is very good as well, no disruption, but that would all depend on planning restrictions.
Okay, good. Ian, another one via email again, just while you're here and unmuted. I'm not sure who it's from, I'm afraid. It just got sent to me from reception. In traditional solid wall buildings, the most difficult areas are often where elements meet, such as where timber joists are built into external stone walls. Of course, joist ends are vulnerable to damp or condensation. Right. How is it best to insulate and vapor seal at these points?
Well, it probably ties in with the question or the answer I gave earlier.
Today.
Your timber fuse and things that you can get for the solutions there. Aerogel is a great answer because it gives you your breathability, so you're not building in problem with those areas around those joist ends. But yes, it's a great point. You should be treating them. And if you're ever concerned about it, again, go back to our tech desk and we can help you as best we can to seal around those areas.
Okay, thank you very much, Ian. Okay, I have 3 questions left, believe it or not. So I will go to Will. One from Ian here. What option is better suited for me with my solid walls? Internal wall insulation or external wall insulation?
Okay, that's quite a few factors that could come into play here. So assuming that you've got the option to do both and that space isn't an issue either externally or internally, so sort of room size or the fact that maybe the property is roadside, it probably depends on the lifestyle of the day-to-day activity within the household. If you insulate internally, then you end up with a higher thermal mass externally, and vice versa. If you insulate externally, then you end up with a higher thermal mass internally. So in short, many people believe that the envelope approach is best. So you put as much of the insulation to the outer side of the property as you can and try and envelope whatever building it is you're trying to insulate. But there is an argument to say that if you're not going to sort of the building itself is not going to be occupied throughout the day, it might just be a professional coming back from work for a few hours, sleeping, getting up and going out again, then you want that property to heat up quite quickly, and you're not going to sort of leave the heating on throughout the day. So if you go and insulate internally in this instance, when you turn your heating on, you're going to find that your building is going to warm up very, very quickly, or at least a lot quicker than if we were to insulate externally. This is obviously because we're not having to heat up the mass of the wall itself. So in that instance, I'd say it's best to go IWI if you can afford to do it that way, and you can afford to lose the space internally, certainly. However, if you're in a situation where you're living in the property all day long and it's pretty much occupied for 90% plus throughout the day, then or some people leave the heating on all the time. It's important to keep that factor in mind as well. You know, there's a belief that if we leave our heating on tick over, or at least at a low temperature, that's going to be more efficient. So I would say in that instance, go for the EWI approach, because you're going to keep the actual walls heated, the actual mass of the wall is going to be heated, and therefore in that instance, when the heating does either get turned down or get turned off, you expect the rooms to stay warmer for longer. So it just kind of depends on lifestyle, but yeah, I hope that again that answered that question.
It does. Fantastic. Thank you very much, Phil. Okay, last but not least, we have a final question here, which is a project-specific one from Ben. Let me just find it back in my feed somewhere. Bear with me. So Ben has asked, Ian, if I can come to you here. I'm sure it'll start with, it depends, but on a 1980s timber frame bungalow refurb project, there's the original thermal foil VCL draped between the floor joists. We'd like to add mineral wool insulation between the joists from the underside, but this would involve cutting out the existing VCL, so they're not intending to lift the floors. Do you think it would be acceptable to remove the VCL in this instance to benefit from increased thermal performance? There's a ventilated solum which wouldn't be affected.
Yeah, not to disappoint, it depends. Ben, I would like to know a bit more as to why you're going to think you're going to have to cut out the foil on the walls to insulate the floor. I think it's a great way to do things on the underside by putting insulation on the underside. And if you can do it from the underside, that's a great way to do it. I think we just need to have a bit more detail on that floor wall junction. I don't think you'll need to cut the foil, but I would just need to get that around my head as to why you need to do that. But yeah, mineral wool, or as I've said earlier, our space therm is a good option because of its vapor permeability in that area. Might be the better option.
Okay, so he can call in, speak to the tech team, and have a bit of a discussion on that project. Okay, fantastic. I think we've come to the end of most or all of our questions. In fact, I lie, last minute one in via email. I don't want to miss it, so I'm just going to pop it to you, Ian, because you're already unmuted just for speed. John has said, I'm about to refurbish a slated roof in West Wales and have been told I should use a breather membrane. Is there any special requirements you would recommend for this location? The residents don't want to move out.
Okay, special requirements for Wales. Won't speak about the rugby. Or they'll be there for ages. I think it's a great point that you're making. West Wales, obviously, it's going to be an exposed area. You've got residents that don't want to move out. Again, that adds to the complexion. Using the breather membrane is always a great option in any refurbishment. Obviously, we have one in our range in terms of roof shield. It's a great point and needs a lot of clarity there. Breather membranes have a great role in any refurbishment job. But you've got to be careful. These membranes are highly water resistant, but not waterproof. And what you need to be careful of, especially in areas like Wales, West Wales, is the water holdout. So if you've got a project where the residents are not moving out, be very careful of the moisture. Breather membranes can be used for a temporary cover, but you may get water coming through them. So if you're going to be leaving the roof exposed at all, I would always recommend, especially if the residents are in, use a temporary cover, a tarp, until such time as you go back the next day and can finish the job off. Do not leave it exposed. We live in a UK climate. It rains a lot, so take that into consideration. The climate change is not helping either. So when it rains, it really rains, like Scottish rain. So be very careful what you're doing, and if in any doubt, use a tarp, cover it up. Once it's slated and tiled, great. But temporary protection, very important, especially if you've got residents in that building.
Good. Matt's coming with the final one, Ian. And again, you've got the short straw because you're unmuted again. Any thoughts on how to best resolve the following issue faced on a project? So within the attic space, the client has found that condensation can form on nails, which then drips onto the ceiling insulation below. The attic is well ventilated and the build-up is a slate roof finish with roof shield below on sarking boards with gaps between.
Yeah, I'm going to mute myself quicker next time. It's a good question, a really good question. And we've had this since we've been selling roof shield for over 20 years, that people say we've got a problem with condensation on our nails, and it must be because we're not ventilating. That's not quite true. You do get problems with nails, especially in Scottish construction where you've got the sarking boards. The nails come right through the membrane, comes through the slates, and you have to be very careful when you're walking about that loft so you don't scald your head on the nails. So it's a sort of physical thing that happens when it's cold outside. The nails get cold, the cold comes into the loft space, and you get condensation on those cold areas. It's a very small cold bridge all over the roof in certain areas. Now that moisture doesn't last for long, and it will be only temporary until it's the time that it heats up. I have been in roofs where people have been very obsessed with it and actually put small bits of styrofoam on each of the nail holes, on the nails, which is quite time consuming, and I think it's probably an overkill doing something like that, because those nails have been sitting in older buildings even before roof shield was invented, and those problems are just temporary. So yeah, it's a possibility, but they are just a temporary problem.
Okay, fantastic. Okay, I think we've come to the end of all our questions. What a fantastic discussion, and thank you for some of the comments on the chat feed around the discussion being good. And this is why we send out our survey at the end of each webinar. So there's some feedback there from Steve, who we know I speak too fast. Noted. I will work on it. But when we send out the survey to you after this, please put your thoughts on it and be honest. Be polite, but please be honest, because we do use the feedback to help improve future webinars, to shape, what they're about, how we do things. So really, we're doing these webinars for our audience. So please fill it out and be as honest as you can with your comments. That'd be fantastic. So again, the date for the diary, Friday the 24th of February, we'll be back at our usual time of 10 a.m. And this is a webinar focused on Airtight products in practice. And we will have special guests from Comfort Frames project delivery team. It helps us if you give us a thumbs up if you enjoyed the webinar and the content today, and also subscribe to our channel for future content. As I said earlier, we're posting a lot more things than just these webinars, so please subscribe and you'll be kept informed of everything. So I'd like to thank everyone for attending. Thank you very much to the panel. It's not easy answering questions on the hoof. I think you've done a great job today, and if anyone has any further questions, then please contact our technical team or sales team, organise a meeting or chat about your project. We're really happy to talk to anyone at any time. So have a great weekend. I hope it's warmer where you are than where I am, certainly frosty up here. But have a good one, and we'll see you on the 24th of February. Thanks, guys.
Thanks, everyone. Bye.
Bye.